Hey guys, I'm Kimchou and this is Yihan. Today we're gonna tell you about car collision, and we are here as a vehicle safety engineer, and we help design cars that are safe and protect occupants like you guys from any accidents. So we're gonna talk about the physics behind car collision and how to stop car collision from happening. This is our car and its name is Kaiman. So first off, we wanted to tell you what kind of material that we use and why. So first off, we use a popsicle to make the structure of the car, foam board as a car cover, plastic folder as the window, metals as the wheels, the three wheels below, circular foam for the car's organ, glue gun to stick everything together, straw as the wheel supporter so that the wheel can be intact with the car and run smoothly. We also put some safety features in the car and we want to share it with you. This 2-seat can protect the egg. Since we place the egg between the chairs, it can protect the egg from colliding with the window or the door. The egg will be restrained in between the 2 seats. We place it there so that it won't be easily thrown away anywhere in the car or even out of the car. The door also serves as a safety precaution to the holy egg inside. We made a sturdy door out of popsicle and also a layer of foam board from the outside. This door serves as a protector of the egg since it's a very sturdy door and it's very hard to pull out, and so it can protect the egg from flying outside. The car that we make have a pretty heavy weight, which makes it harder to just fly off when we get hit by a pendulum. Although it jumps up a bit, but then it also lands back on the ground and moves forward when it gets hit from the back or the front of the car. As it hits the wall, after seeing the collision, do you wonder how does it relate to science? Let's first start off with Isaac Newton's law. The first law of motion states that an object at rest stays at rest and an object in motion tends to stay in motion with the same speed and in the same direction unless an unbalanced force acted upon it. The car on the table wasn't moving anywhere. It stayed in the same position that we put it, and until the piece of wood struck it from behind, applying force to the car, making it change its motion, and the car rolled forward to hit the wall with its own force. So the second law of motion. Let's start. The situation began with the car traveling at a velocity of a certain amount and upon colliding with the wall ending with a velocity of 0 when it stopped. The force of this situation is defined by Newton's second law of motion, which uses the equation of force equals mass times acceleration. In this case, the acceleration is v minus 0 divided by t, where t is whatever time it takes a car to come to a stop. If that velocity is 0, then the object remains at rest. If an external force is applied, the velocity will change because of force. For an external applied force, the change in the velocity depends on the mass of the object. This is the formula for the second law of motion, F equals m times A, which in this case m is equal to 205 gram, which we converted into kilogram, which is equal to 0.205 kilogram. And we have to find velocity of the car in order to find the acceleration. So the velocity is 100 centimeter divided by 4 seconds, which equals to 0.2 meters per second. Acceleration is equal to 0.25 divided by 4 seconds, which equals to 0.0625 meters per second square. So there we have it. F equals 0.0625 meters per second square times by 0.205 kilogram, which equals to 0.0128 Newton. So there we have it. Our force is equal to 0.0128 Newton. The third law of motion states that for every action or force in the nature, there is an equal and opposite reaction to it. In this case, when the car slams into the wall and it bounces back by some inch because the wall doesn't break or move at all, the full force of the car into the wall has to go to somewhere. And so the car exerts this force in the direction of the wall, but the wall, which is static and unbreakable, exerts an equal force back on the car, per Newton's third law of motion. And that is the reason why the car bounced back from the wall an inch or so. This equal force is what causes car to accordion up during collision. So now let's move on to another interesting topic that relates to energy, speed, impulse, and momentum. Let's find out how it relates to the car collision. Momentum is a physical term, and it refers to the quantity of motion that an object has. The amount of momentum that an object has is dependent upon two variables: how much stuff is moving and how fast the stuff is moving. This car collides as an elastic collision. So in this collision, both momentum and the kinetic energy are conserved, meaning that the kinetic energy is not transferred to anywhere or transformed into any other form. The total system kinetic energy before the collision equals to the total system kinetic energy after the collision. And this is the formula for momentum. Momentum is equal to mass times velocity, or P equals to mass times velocity. We have P equals to 0.205 kilogram times 0.25 meters per second, which equal to 0.0512 kilogram per meter seconds. Impulse is a force applied to an object for a certain amount of time. When you apply a force for a certain amount of time, you create an impulse. In fact, that's the definition of impulse. Impulse equals a force applied multiplied by the time it was applied. Here's the equation. Impulse, or J, equals to F times T. Impulse equals, or J, equals to 0.0128 Newton times 4 seconds, which equals to 0.0512 Newton per second. Energy has a capability of moving things. It can move things, heat things up, cool them down, join things, break things, cut things, make noises, make light, and power our electronics, etc. There's so many that energy can do. But the thing is, energy cannot be created or destroyed. It can transform from one form to another. And in this situation, our car collision is an elastic collision. This implies that there is no dissipative force acting during the collision, and that all of the kinetic energy of the objects before the collision is still in the form of the kinetic energy afterwards, meaning that the kinetic energy did not change even from the start to the end of the collision.